My name is Eleana Georgousi, and I will present today my paper I did for UCL Bardar School of Architecture, exploring alternative rules of distribution of points of interest in location-based games based on spatial configuration and visibility. My research question is if configurational theory of space interests can be used for the placement of points of interest for gameplay in the city, taking into account the player's position and location and the surroundings. First, I did existing location-based games and analyzed their distribution and logic. Specifically, I selected the location-based games Pokemon Go and Ingress. One objective of this analysis was to investigate how the points of interest of these games are distributed in central London. Parameters such as the level of centrality, accessibility, connectivity, open space, visibility, obstacles, or do they depend on sit down or green space? I also explored how to evaluate games through the use of space inverse spatial measures. Location-based games is the physical space where players perform gameplay. This research focuses on game spaces that represent real-world spaces. The players use their experiential knowledge of the real space to navigate in the city, the game world, and the 2D map in their smartphone to inform their gameplay decisions and to show them the next point of interest. In the real environment, a game designer cannot change the geometry of the space, but he can use the visibility and speciality of the existing space for different purposes and functions. In Ingress, players are equipped with a map of portals, which are located throughout the real world, repurposing public landmarks into points of interest for the game. In Pokemon Go, players can directly interact with 3 different point datasets in the game, which are Pokestops, Pokemon gyms, and spawn points. They exist not only as physical nodes and digital representations. These points of interest locations in the real world and are almost entirely community sourced. Players use GPS to move in the real world and reach certain places which are of interest to the game. There have been noticed significant correlations between attributes of spatial configuration of the environment and pedestrian movement. Many theoretical advances have been made for the development of new techniques for the representation and analysis of space. Architectural theories and methods of configurational analysis, such as the various space syntax techniques, were used in this research to form an alternative logic of placing objects in the real environment in location-based games. Space syntax measures offer a way forward in developing the methodology of this research, especially street network analysis and visibility analysis. Also, one important thing to consider space are the landmarks, which are the main points of interest in the location-based games Ingress and Pokemon Go. So this is a methodology diagram of this research, and using space, I explored a new logic of placing the points of interest in location-based games using visibility, speciality, and proposed new placements. I also suggested a combination logic of landmarks and space syntax. I used the Ingress Intel map to actions of the Ingress portals, and also extracted the landmarks of central of London from digital, and I used the interactions to combine them with the new possible placements of points of interest. Since it was noticed that geography affects the number of ingress points, I initially selected 3 study areas with different levels, such as central and touristic area, a suburban, and a rural area. Results showed that portals, which are crowdsourced data, occur more frequently in central and touristic sites. Location-based games can aim to make them equally accessible accessible, for instance, by placing extra resources such as different logics of distribution help areas that are underrepresented in data coverage. This research also investigated if we select a path, the shortest route from an origin to destination, how many points of interest will the players come across. I explored the portals from Ingress and the gyms from Pokemon Go. It can be noticed that the distribution of portals is very good in central London. For example, in a 20-minute path, the player came across to 32 portals and 7 gyms. So spacing techniques can identify places that attract higher or lower levels of urban flow than others and the level of accessibility. The street network analysis was extracted from space signals open mapping, and in the first diagram, the choice measures movement flows through spaces and is described as the distribution of movement. The integration shows how accessible the street is. The visibility analysis measures used in this research, the connectivity graph, which can show how much space you can see from a location, the ISO mean radial metric, which can identify how close a person is to an obstacle, such as a wall or a building, the ISO max radial, which detects the long point, the true vision metric, which can be used to identify locations most likely to be traveled, and these areas are important for movement. So one objective of this analysis was to investigate how the points of interest of the games, Ingress and Pokemon Go are distributed in central London. Some quick observations are that the player is more likely to find many points of interest in the most connected streets. Also, a lot of points of interest are placed in smaller spaces, approximately in space close to obstacles, walls or buildings, and less in squares or parks that are wide areas and in spaces that do not have long lines of sight. The table shows all the spatial analysis measures used in this research and how they were used in the game logic. I integrated certain locations to the game over others, which offer different features according to the spatial analysis metric selected. So choosing the highest connectivity values, these placements can be for objects which are easy to find. For example, in Pokemon Go, these placements can be for the most common Pokemons. So these new placements are placed in position in the city, highly visible for the players. Choosing the highest ISO of these mean values, these placements can be suggested as meeting points, events, for Ingress gathered or work in groups and should be located in open and wide spaces. In Pokemon, be suggested as possible locations for gyms, where players fight each other in the game and a lot of people are gathered. These new placements are placed in spaces that are 20 meters and furthest from an obstacle. That means they are not placed in narrow streets, but in squares, parks, and wide. Choosing the highest ISO max values, these placements can be for objects which the player can locate from a distance. For example, in Pokemon Go, these placements can be Pokestops locations that you can discover from a visual distance. So these new placements are placed in space with long lines of sight. Choosing the highest true vision values, these positions are most likely to be passed a lot by the players and can be for objects which are easy to find. For example, in Pokemon Go, these placements can be for the most common Pokemons. Those values, the new placements were placed in the most connected streets from the player. In streets with high integration values, the new placements were placed in streets where players would end up more often. So this research is exploring new ways to use physical locations as play spaces and how to make use of the possibilities that are distinctive in the space. Space syntax measures offer a starting point to consider certain locations over others within the game environment. New positions for the points of interest in location-based games are proposed, which offer different features in the game logic according to the spatial analysis metrics selected. The games can benefit from the following information and build on it rather than be designed without taking the city into account. Some existing portals are close to the proposed placements each major gave. These portals can be categorized services and factions in the game. For instance, some can be visiting positions, others can be areas that are passed through a lot or occlusive areas. These metrics can also be combined in order to offer a better distribution in the area. Finally, another logic is also proposed, a combination of space symbols and landmarks, which can add additional values to the landmark-based approach. This is the end of my presentation. Thank you for giving me this opportunity.